In this video, we are looking at making connections through inquiry. Here are the two focus questions for this activity. The first, how might inquiry be used to develop students' understanding of energy over time? And the second, how might you adapt this approach for each learner? Here are a list of the suggested learning outcomes that could be achieved for this activity. It includes Physical World 6, Nature of Science 9, Biological World 6, Earth and Space 6, Chemical World 6, and Biological World 8. By engaging with this type of learning experience, students engaging with a Level 2 learning program can achieve some of the learning outcomes in their Priority Learning Units or PLUs. Here are some from Communicating and Literacy. I'll just give you a moment so you can read them. And more from Preparing for Work. I'll just give you a moment to read those as well. Of course, depending on each individual student who engages with the Level 2 learning program, this list will vary and is not exhaustive. In his book, Powerful Ideas of Science and How to Teach Them, Jasper Green outlines 3 bridges to develop students' understanding of abstract concepts. First is observation, so looking at observable empirical phenomena that motivate scientists to formulate their abstract ideas in the first place. Here he gives an example of a ball falling towards the earth. The second is models, using the idea alongside models such as water moving between reservoirs of different heights to express how energy transfers between different stores. And third, confirmation. Going back to the water model above, the idea here is that thinking about energy as a quasi-material substance, and by that we mean seeing energy as an invisible substance that can flow and is the same wherever it is. This slide shows what the 3 bridges for the soil battery activity may look like. I'll give you a moment to read what's on the slide. So now what? Students may wish to use the Scamper poster to build upon this learning experience focused on inquiry. For example, could the soil become even more conductive by adding lemon juice or vinegar to the soil? Perkins designed 4 questions to allow students to revisit and reinforce their learning. They're shown on the screen here, and where there is a blank represents where the topic being discussed would be. So the first is, what are the essential characteristics of blank? What does blank have in our everyday lives? What does blank look like? And what is the value of blank? So if we go now and apply Perkins' 4 questions to an inquiry-based investigation. In the following example, the 4 questions were completed for the topic of a soil battery. The responses to the questions are suggestions only, as the response relies on the prior knowledge of the participant. So what are the essential characteristics of a soil battery? The soil acts as the power source. What use do soil batteries have in our everyday lives? Harnessing the chemical energy caused by the microbial life within the soil acts as a source of renewable energy. What does a soil battery look like? A sample of moist soil is placed into each of the compartments of an ice cube tray. Copper wire is used to connect the screws placed into each of the compartments of the ice cube tray. What is the value of a soil battery? Soil is an abundant resource that is accessible to many people. However, as the chemical energy within the soil is caused by microbial life, healthy soil is essential for making a soil battery. Take some time to consider how this approach of the 3 bridges could be applied to track the evolution of other topics. Next, we will look at the method for completing the soil battery investigation. 2 things to note. The first is that this is adapted from the National Saturday Club, and that galvanized steel screws are covered in an element, usually zinc, to help prevent rusting. However, that is what also helps the screw to conduct electrical current. 1 galvanized screw is needed for each cell of the ice cube tray, but also iron nails can be used. So here is a picture of a soil battery, with the soil tightly packed into each ice cube slot, with the galvanized screws sticking into the soil in each cell. So the first step is to add enough water to the soil to moisten it, and just be careful not to over-saturate the soil with water. Next, cut the copper wire into strips approximately 10 centimeters long and be sure to remove any insulation. Fill the ice cube tray with moist soil and wrap a length of copper wire around the top of each screw except for one. Push a copper-wrapped screw into one section of soil and the loose copper wire end into the adjacent section as shown in the image. Next, in the same section of soil as the copper wire end, push in the next copper wrapped screw to connect each section until the screws are arranged in a U formation. This means there should be two adjacent sections that are not connected as shown in the image. So next, in the section with just a copper wire inserted, insert a screw that has no copper wire attached. In the adjacent unconnected section, insert a loop of copper. Then, using the single screw and the copper wire loop as your contacts, close the circuit with your bulb, voltmeter or any other appropriate device that has two connection points and can show a current is flowing.